Good day to you children. In today's class we will be studying about your 8th chapter, that is motion. And so far what you have studied in science and what you have observed in your daily life, what we can describe two situations for any kind of object, and those are, one is motion and the other one is rest. So based on your observations, what is rest and what is motion? First, we have to answer these two questions before we delve deeper into the chapter. So, what is rest? And children, keep in mind, whatever I say in this video or write or even draw, everything must be present in your fair book. And whatever homework I give you through these video classes, they must be present in your homework book. I am not going to give you any kind of separate notes for this. Alright. So now let's first understand what is rest. The very first thing we have to understand, or the condition which is very important for us to understand motion, is known as rest. Whenever we usually associate the word motion with the word movement. That means when the bodies or the objects move or when they change their places, then at that time we say that they are moving or they are in motion. So when we talk about rest, rest is the condition where an object does not change its position, or it is a condition where the object does not move. For example, whenever you just sit in a place in your room or in your classroom or in your home, whenever you just sit in a place, then you are not changing your position or you are not moving. That condition is known to be rest. Similarly, another example is the trees. The trees are fixed in a particular position in the earth, so they cannot move. Whereas the table, chair, houses, mountains, soil, all of these materials are immovable. They are at rest. So to answer the question what is rest, the answer is when an object doesn't change its position with time. Okay, time is always constantly moving. Time doesn't stop for anyone. So when an object doesn't change its position with the time, or when an object doesn't move with the time, then we say that it is in rest. So when an object doesn't change its position with the time, it is said to be in rest, or it is said to be at rest. For example, trees, mountains, houses, etc. They are all at rest. Now coming to the question, what is motion? The second question, or the second condition which is the topic of our discussion, is motion. So what is motion? What is motion? So motion is the opposite of rest. Whenever the bodies change their position with time. Alright, this is the proper definition. When a body or when an object changes its position with time, or when it moves with time, it is said to be in motion, or that condition is said to be the motion of that object. So let us write it down. When an object changes, right, here it doesn't change. In rest case it doesn't change, but in motion the position of an object changes. When an object changes its position with the time, it is said to be in motion. For example, winds, cars, cars or any kind of vehicle which moves, they change their position. So they are examples for motion. Similarly, earth or planets. Planets are in motion. The stars are in motion, etc. And motion is classified into different types based upon what kind of path that object traces. For example, if an object travels in a straight line, then it is known as rectilinear motion. When an object takes curved path, it is known as curvilinear motion. When an object traces a circular path, it is called as circular motion. And whenever an object oscillates, that is to and fro, it moves to and fro, that is known as oscillatory motion or periodic motion. Relativistic nature of motion means, I'll give you a situation, just try to imagine it. So imagine that you are sitting in a bus. Alright, there are several other passengers with you. So now the bus is moving, It is imagine that you are coming from CBT to your school. So the bus is moving, and when you look at the other passengers who are sitting in the bus, you will see that they are also at rest. Your point of view, the other passenger who are sitting in the bus are not moving, they are at rest. But from someone who is looking through the window, who is looking from outside through the window into the bus, the passenger's position is going on changing, right? So if say the bus stops at Jubilee Circle, then and someone standing at the Jubilee Circle looks at you or the passengers through the window, then you guys look to be in motion for that person there. So but how can this happen? How can rest and motion exist at the same time? For you, everybody is at rest who is inside the bus, but for a person outside the bus, all of you look to be in motion. So rest and motion exist simultaneously. That is, this kind of situation where rest and motion exist at the same time is known as relativistic nature of motion. It means it is simple to understand. Motion depends upon the position of the observer. Relativistic nature says motion, the condition of motion or rest depends upon the position of the observer. Here observer in the bus in the example which I just gave, here the observer in the first case, that is when you are sitting inside the bus, you will be the observer. But when someone is looking from the outside, that other person will be the observer in that case. Similarly, there is another example which I can give you. Right now that you are on earth and you know that earth is rotating and revolving. Earth is rotating around its axis and it is also revolving around the sun. But for you, do you see your mother rotating with earth who is also with you, or your sister or your brother or any family member? Do you see them moving along with earth? No. Obviously you see them to be at rest at home with you. They are not changing their positions. Alright. But if you were to go to the moon or sun or Mercury or any other planet or any other natural satellite, or you will observe that your family member is changing their position with respect to earth. They are rotating with the earth and also they are revolving around the sun with the earth. That means motion depends on from where you look at it. If you look at an object standing on the earth, then it will appear to be at rest for you. if you stand on Earth. But if you go to some other planet like Moon, some other satellite or planet just like Moon or Venus, then you'll see that that object on the Earth is moving along with the Earth, our planet. So this shows that motion is relativistic. This whole thing was worked upon and the theory was developed by none other than Albert Einstein. So which it's a very important concept which you'll be studying in your higher studies if you select science. But for now you need to understand that motion is relativistic. That means it depends upon the position of the observer. So I'll write down the next point. Rest and motion can exist at the same time. For example, a tree on the earth appears to be at rest for an observer on earth, but for an observer on the moon, it appears to be moving with the planet. Similarly, you can give many more examples for the relativistic motion. Motion is relative in nature. So that whenever we define motion, we mention two parameters. One is the position of the object and the second is the time. Alright, so based on the position of the object we have two types. So write down the side heading, position of the object. So suppose an object is at point A and I want this object to travel to point B. So how many different kinds of paths can this object take to travel from point A to point B? There are infinitely many paths that this object can take. Say for example, the object can come like this. These pencil marks noted the path taken by that object to denote that path. So see here, the object can come from A to B using this path, or it can take a path like this, or it can even have a semicircular path. Alright, and also it can take a direct straight path. So here we can see that there are two kinds of path that an object can take. The first three paths are known as the distances, whereas the straight line which joins any two points is known as the displacement. Keep in mind these two concepts are very important as they define two very major physical parameters which we measure during study of motion. So the first kind of change in position is known as distance. When we talk about position. We mean change in position, because in motion we study the change in position of an object. If an object moves from point A to point B, then what kind of path it has taken, and that is defined as either displacement or distance. So the very first kind of change of position is known as distance. It is defined as actual path taken by an object. Actual path taken by an object. In the figure, the path 1, path 3 and path 2. All these three paths represent the distance covered by an object, whereas the fourth path, that is the straight line, is known as displacement. This is the shortest path taken by the object between any two positions, and from one point to another point, the shortest path is definitely a straight line. Euclid's axiom number 1. Displacement. Distance is denoted as small d, whereas displacement is denoted as small s, and both their units are meters, since they are length is measured in meter, so both of them are lengths, so their unit is meter, SI unit is meter. And displacement is defined as the shortest path taken by an object. Whenever we travel by road, by train, by air or by water, we measure distances. We do not measure displacement. In day-to-day life, we use the word distance more than displacement, because we actually take the longer path to cover to reach from one point to another point, whereas displacement is usually used in measurements of atomic particles like electrons, protons. The path taken by those particles is all light. The path taken by those kinds of physical quantities is measured in terms of displacement, whereas in every day-to-day life we talk about distance, and both their SI units is meter. So another way to understand distances and displacements is, consider an object at O. Okay, initially the object is at O, point O, and then it moves from O to point A. Then it comes to point A, and at point A, the distance, the length between points O and A is 10 meters. Then the object moves forward to point B. Then the object from A, it comes to point B, and the distance between both A and B is 5 meters. So first let us write these down. First it was at O. The object was at O. Then it moved to A, and then to B before coming back to the point O. Coming back to the point O. So now the object has traveled from O to A to B, then again straight back to O. Alright, so how much distance did this object cover? We know the distances here. We know the length between each of these points. O to A, it is 10 meters, and A to B, it is 5 meters. So how much distance did the object cover? So first, to calculate distance, the object started from O, it went to A, then from A it came to B, and directly it returned to O. So the total distance is the actual path, no? So total distance will be OA plus AB plus BO. The length OA plus AB plus BO, which is equal to OA is 10 meters plus AB is it is 5 meters plus BO is 10 plus 5, 15 meters. So the total distance covered by the object is 30 meters. It went from O to A to B and then it came back to O. So this was the distance. When we talk about displacement, look at the initial position and the final position. The initial position of the object was O. Initial position was O, and then the object once again came back to the position O. So O to O, what is the displacement? The shortest path for the object to go from O and come back to O is how much? It is equal to 0 meters. Even though the object covered a certain distance, its displacement can be 0. Displacement can even be negative, but the distance cannot be negative. Types of motion. Previously in the types of motion, it was dependent on or categorized on the basis of what kind of path the object traces during its motion. If the straight path, then rectilinear and all that. Now in this kind of types of motion, we study how much distance is covered in how much time taken. So based upon the distance covered, write it in the brackets, based on distance covered. Based on how much distance is covered in given time, we classify motion into two types. The first one is uniform motion. In this kind of uniform motion, equal distances are covered in equal intervals of time. Say an object starts at 0 seconds. After 10 seconds it has covered 10 meters. Then next 10 seconds it has covered 10 meters. Next 10 seconds it has covered 10 more meters. So when an object covers equal distances in equal intervals of time, it is said to exhibit an uniform motion. Write it down. When an object covers equal distances in equal intervals of time, it is known as uniform motion. And second is known as non-uniform motion, when an object does not cover equal distances in equal intervals of time. That is when an object does not cover equal distances in equal intervals of time. Say for example, starting from 0 seconds, in the first 10 seconds the object covers 10 meters. In the next 10 seconds it covers 5 meters. In the next 10 seconds it covers 15 meters. This kind of disparity in or non-equal distances covered in equal intervals of time is known as non-uniform motion. For example, in your day-to-day life, every vehicle that you travel exhibits a non-uniform kind of motion, whereas a pendulum of the clock or the minute hands or second hands of the clock show or exhibit the uniform kind of motion. They are the best example to describe these two kinds of. So the next concept is speed and something known as velocity. Speed. First, let us discuss speed. Speed is the rate of change of distance. Whenever we talk about distance, we talk about speed. Speed is the rate of change of distance of an object with time. So it is we usually in your textbook, speed is denoted as speed itself. They have written speed in small letters, but usually we denote speed with small letter s, not to confuse it with displacement. Let us write speed is equal to, mathematically, speed is equal to distance upon time taken. SI unit of speed is SI unit. Units are extremely important, so make sure, children, that you always remember the SI units. So SI unit of speed is meter per second, which can also be written as, in the exponential notation, meter per second. Both are one and the same. So speed is when distance changes with the time, we talk about speed. Whenever the odometers of the vehicles which are present in your car or bike, they measure speed. They do not measure velocity. They measure the speed. Now coming to velocity, name it as A. Coming to velocity, velocity is the rate of change of displacement of an object with time. In simpler words, it is time rate of change of displacement. So when displacement changes with time, we talk about velocity and not speed. And velocity is denoted with small letter v. Small letter v, which is equal to s by t, or displacement by time is denoted by small t. Displacement by time. Again, the SI unit of velocity is same as that of the speed. So SI unit is meter per second, which can also be denoted as meter per second. Both are one and the same. So this is all for today's class. In the next class, we'll study about average speed, average velocity, and the acceleration, the concept of acceleration.